Hi, welcome to the second in the series on cloud security from Cado. This one is on cloud security fundamentals for forensics and incident response. My name is Chris Doman. I'm the CTO and co-founder of Cado, and with me is Paul Scott.
Everyone, yeah, I'm Paul. I'm an R&D engineer, so I mostly work on kind of thinking about new things to add into the product and helping our customers get the best out of what we do.
Thank you for agreeing to be roped into this today, Paul. Okay, kicking off with the basics. What is infrastructure as a service versus the alternatives?
The way I think about it is the further you go to the right on this picture is how much you can care less about looking after stuff, obviously at a cost from someone else. So on the left-hand side, you have to care about everything from the power bill all the way up to the application that's running. When you start moving over to infrastructure as a service, you don't need to care about hardware. So if a drive's failing, someone does it for you. The power bill is kind of factored in already. If you move on one further to the right, platform as a service, all you need to care about is your app and data. If something breaks there, it's still up to you. And all the way to the right, if you're doing software as a service, all you care is about web browser and what goes on in that page. Everything else is handled for you. How is IR different? Basically, data access is the main thing there. Software as a service, you have essentially nothing, maybe some logs. On site, you have access to everything that you can get your hands on. In between is where it gets a bit more interesting.
Nice. Biased question here, but do you have a preference of like what kind of IR you enjoy the most?
So I would say I'm definitely cloud now, but as that's coming from a background of on-prem, so I think it's good to have an experience of both, because not all the problems are the same, but a lot of them translate over or they have some sort of minor difference. So a lot of the on-site problems still exist in the cloud or are slightly different, but the cloud also has new problems as well. So it's definitely good to have a background in both.
Yeah, I guess on that too, have you seen many investigations where it ends up being a hybrid? So like there's some kind of SaaS plus some actual on-prem stuff, or does it generally kind of stay in one location?
Yeah, I mean, usually it is. If something ends up in the cloud, it usually does start off with something more on-prem. So it's like phishing is by far in the way the most common way that a compromise starts. The second most that I've seen is VPN endpoints that are that have known kind of vulnerabilities and they're compromised. But most of the time it goes user compromised credentials, then move into the cloud environment, unless you're talking about misconfigurations where they go straight into the cloud, such as open buckets and things like that.
Yeah, we'll get onto that in a second as well. Plenty of open buckets to talk about. And then again, I'm sorry for talking about something that everyone is sick of hearing about, but what is shared responsibility, and is there any relation to here in terms of incident response, in terms of where that barrier kind of sits?
Yeah, so shared responsibility is usually talked in context of AWS, but it's basically the dotted line between the whose problem is it basically. So at the very low level of all the hardware and things like that is, me as a customer, if a hard drive fails in an AWS data center, I don't care. I don't want to know about it. It's their problem. However, if my EC2 is compromised because I left a vulnerable service on it, that's up to me. So that's that kind of that dotted line where, I have to deal with everything from here onwards. AWS deals with everything up to that point. It's not to say that AWS won't step in and say, by the way, we've noticed this happening. You might want to look at this, but that's very much, it might happen. They're not claiming liability there, which is the key point.
Yeah, I guess it's interesting too, as it goes beyond just kind of proactive warning stuff and into instant response too, where AWS is hiring a lot of IR teams and they can potentially help you, but there's that's not their job either, right? If you have like a compromised EC2, it's your job to respond to that.
Yeah, I mean, you can pay for services as well, but they're much more geared towards like IT ops and uptime rather than security investigations as well.
Yeah, I mean, that's a good point too, right? Where this goes beyond their kind of implicit requirements, where they should just do it because it's good for everyone versus a service as well that you're paying for. Then on to the next one. I mean, this isn't such a popular phrase, I guess, but I just thought it was an interesting kind of contrast that Google came out with recently, perhaps a bit competitively here, whereby Google are quite big on enabling you to use their IR teams. Mandiant now, obviously, they've brought out as well, and also kind of running that through their cyber insurers. Yeah, I mean, this is more like a kind of like a marketing thing, I guess, in some ways. But why don't you have got anything else to add here?
Yeah, I think other than the kind of the insurance kind of IR provider, which does seem a little bit different to anything I'm aware of AWS doing, but the first 2 points on shared fate. AWS do the same thing. They might just not market it in the same way. So like they do provide free tools and resources for kind of making security better. And they do also help, give tools for compliance management as well. It's just being marketed in a different way, I think.
Sure. I mean, to their credit, AWS has done a lot of, like you said, free tools and kind of moving more that way as well, particularly on the response side. Cool. Another classic. We all know what IAM is vaguely, but in particular reference to like incident response. I mean, at a high level, what's IAM, and are there any kind of DFIR considerations there?
Yeah, it's interesting. So IAM is just a mechanism for saying who are you and what are you allowed to do, basically across the whole cloud environment. And it becomes interesting in IR because in an on-prem environment, if you want to add a server, someone has to buy it, lug it over to the data center, rack it, and install it. So it's a lot more difficult to just put new servers in. But in the cloud, I can just go click, 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 and I've got new servers. So you end up with what the old kind of shadow IT thing, but it's shadow cloud IT, and that can be compromised, and nobody can know what it is. So you have this issue where your IR team might not have the IAM access to get into the thing they need to investigate. Nobody might know who owns it and who can give access to it. So that becomes a really interesting problem of access to data. Logs is an interesting thing as well, because it's really easy to get loads and loads of logging out of the cloud, but you need to turn it on and you need to manage the volume particularly, because it can get pretty insane pretty quickly. That happens in on-prem as well. Like if you turn on audit logging on a Windows box for every folder access, you're going to get trillions of logs. That's not particularly useful. So it's like I was saying earlier, some of the problems are the same. It's easier to get the logging in the cloud, and it's easier to get data access if you do it before an incident, and that's the key thing. But attacker access generally is the same way that it's always happened. It's phishing, compromised credentials, and then lateral movement. That lateral movement looks a bit different nowadays with the cloud, especially if it's a completely contained in the cloud incident, where you can kind of move, basically doing IAM lateral movement through services.
Yeah, I guess it's interesting too when you talk about some of the differences there. And I think about like an old, kind of compromise on a domain controller or something. You're talking about access there. Even the logs are gone, at least you still have a chance of finding something because you own that server, right? But on the IAM side, the logs weren't turned on, to your point. Yeah, I mean, you're probably not going to find much, are you?
Yeah, it's even worse if you start considering things like ephemeral infrastructure. So, it's one thing if the server's still there and you can try and do a kind of traditional forensic capture of it, if it's an EC2, for example. But if you're thinking about things like, an EKS cluster and you haven't got the logs turned on and you haven't captured it, you've got nothing to work with essentially there.
That fits in perfectly with the topic coming up in a second, actually. Jennings, the next slide, though. And then, still running through the basics, that's super quick. What's VPC? Any relation to IR and DF?
Yeah, I mean, a VPC is basically a direct translation from a kind of a switch, multiple switches attached to a router kind of in the cloud. So each subnet is a switch, those subnets attached to a router on the edge. And if you want, you can plug it into the internet. So on the diagram here, that internet gateway is the big internet cable. The router, familiar with any kind of networking, that will give you inter-subnet routing, and the switch will deal with one thing talking to the other thing on layer 2. How does it deal with IR? It's just exactly how it would on-prem. If you've got a compromised computer that's networked to another one that can be moved laterally to, they can talk together. It is a lot easier to kind of apply security kind of constraints on things though. So it's much like you would do on a managed firewall appliance, for example, but you can do that kind of built into the VPC. So you're not needing to kind of pay for an extra kind of firewall appliance and things like that. If you want the really detailed stuff, you will need to kind of add some more complex technology on, perhaps start paying extra stuff or extra fees. But you get quite a lot of kind of ability to restrict kind of communications out of the box.
Yeah, I never really thought about it as a switch, but you're right, that's it. Cool. It's still burning through here. So some of the common attacks in the cloud. I mean, what are some of the common attacks in the cloud?
Yeah, so I'll just run through these quickly, but I think the main two anyway, are misconfiguration and resource hijacking. So misconfiguration are a bucket that's not supposed to be public. It may have started off private and is made public by accident, or maybe even maliciously, depending on what's going on. But you don't want your big bucket full of your finance reports or customer data being made public so everyone can download them. That happens a lot, and there's loads and loads of red team tools out there that just scan for buckets based on names, or you can give it kind of word lists to look for that, and it'll try and kind of download stuff from that. Also a great opportunity for lateral movement as well. If you can get things that will give you further access, like credentials or Terraform state files, for example, that might have you can move using them. Stolen credentials, phishing, again, as always, big one. More interesting though is when you're talking about the cloud, you're much more likely to be using things like infrastructure as code and kind of versioning control and stuff like that. So a lot of people accidentally push API credentials or things like that into Git, and then people scan for that as well and can really quickly jump in. And that's gotten so bad that companies like GitHub will do that scanning for their customers to try and stop it, because you can push an API key into a repository, and within seconds, someone will have pulled it and tried to use it. So very much kind of like old school, like worm kind of behavior, but from API creds. The poison gold image is much more interesting. So like images, in a virtual machine has been an idea for a while, but when you start to think about containers, say you've got a cluster that's spinning up and spinning things down, and every time it spins one up, it pulls in from a repository. If I can get access to your repository and change something, I can then get it to do something else, and maybe even use that to, resource hijacking is one way. I just might want to mine Bitcoin on your bill, but you might be able to use it to abuse the access that the cluster has. So I might get access to just your repository, but then use that as a springboard to get further into your environment. That's quite a specific one to the cloud. Not to say you can't use containers on-prem, but it's much more likely to be used in the cloud. S3 we've already talked about a fair bit. So yeah, open buckets are bad, and people really like open buckets.
Yeah, I mean, it seemed like a couple of years ago, every week there was a different, accidentally left open S3 bucket issue. But I mean, to their credit, they have gradually been locking that down. So default private buckets, all that kind of stuff now, which does seem to be making impact.
Yeah, there's lots of tools built in that allow you to, like, for example, alert on, even if someone's allowed to make a bucket public, like you can send alarm bells ringing when that happens, and have lots of automation built around that as well.
Yeah, but as the canonical example, right? Every cloud security tool that's there in their screenshot, warning, S3 bucket, set open. Cool. And then kind of following on from that, how might you have a problem if you're in one of the big cloud providers?
Yeah, I mean, you've got your normal kind of things that you'd expect from on-prem. So any security tooling you've got that's installed on a system or things like that, or you might get emails from your customers or people who you deal with saying, I got this weird email from you. That may be a compromise that started in the cloud or has gone through the clouds. Email from AWS is a classic, because they kind of watch out for very obvious abuse of their infrastructure. So if you've had stuff compromised and it's getting used to scan the internet and try to compromise other people, they'll ask you to sort it out, or they'll kind of close your account or close the systems down for you. Another fun one is suddenly getting a huge bill from AWS because someone has gone in and spun up loads of GPU miners and you didn't notice until it's too late. Sometimes AWS will be nice and not make you pay for it. Sometimes they will. They're probably the two most common cloud-specific ones. If you're actually taking an active look, you might find kind of unusual IAM permissions that have been set that shouldn't have been. Especially if you're looking at things external to your environment, like you might see a bucket or a resource that's being shared with another AWS account that's not in your organization. That's probably something that will stand out more than just normal kind of people giving each other access inside the organization.
Yeah, I mean, particularly on that increase in billing, it's great to set up billing notifications. If you're watching this on YouTube because you've just had this happen to you, it is actually unfortunately quite common. As Paul said, that AWS are pretty nice sometimes. We talk to them, you can get that bill reduced, particularly if like you're a student and you've had your account hacked. And there's a thread actually pinned to the top of the Reddit AWS talking about how you can negotiate with AWS there, and similarly with Google and Azure too, if that happens to you. Hopefully it hasn't though. And a controversial one from Florian Roth, controversial person. He likes to kind of stir a bit. Is DFIR in the cloud just logging?
I think it's more logging to an extent, and it really depends on the services that you use and what kind of tooling you have available to kind of get access to stuff. So, if you're just using, say, only Lambdas or Beanstalk or something like that, where you're very far to the right of that picture we saw earlier, where everything's managed, it is mostly just logging. However, if you're not all that hard, right? There is stuff that you can do. There is access to data if you have the right tooling and the right things set up ahead of time. Even not ahead of time, you can set stuff up and still get access to more historical data that's of a more traditional forensics kind of type. So I would agree that you probably need to care about log availability more than you did on-prem. You still had to care about it on-prem, of course, and if you didn't, you'd still be in trouble, but you had the historical artifacts to fall back on because you didn't have the concept of a magic cloud box that doesn't have any access to it that you do now. So I agree to an extent, but not fully.
Yeah. I guess my view is that if you're relying just on logs, you're going to be missing at least half of what happened, particularly for something more serious. But also, I mean, at least I am massively biased because I work for a company that helps you get that other data. So, take it as it comes. I'll skim through these because, frankly, if you're interested in where to get logs, the resources from AWS, GCP, and Azure are kind of places to go. But I mean, high-level pool, anything in particular on AWS logging that you want to raise?
Yeah, the main thing is, as the picture shows, that CloudWatch is generally the middle, and I think that all three of the big providers have the same kind of rough structure where you have one product is the kind of the aggregation point where you can kind of pipe logs into it. So in AWS, CloudWatch is that, not a seam, but it's basically like the log viewing kind of central point, and you can export them to S3 as well for archiving. And there's various kind of different types of logs and ways to look at it, and you can set up kind of alerting based on logging and metrics and all that kind of stuff. And it's roughly the same across all the main CSPs. They have different names and they have slightly different structures, but it generally works out in the same way. So if you understand how it works in one, you learn the names, you'll generally understand how it works in all three.
Yeah. We've got, I think we actually got a dedicated talk just on logging coming up at some point soon, but there's so many different places potentially where logs can go. I mean, like you said, CloudWatch is generally a good place to look. Some go to S3, some go to like a console view. And then there are tools like Athena you can use to analyze them too. There's a whole bunch of stuff that could go into here. Same question as I mean, where's kind of the first place you'd look for logs in Azure generally? Or
yeah, I mean, as before, it's pretty much the same. So if you're wanting for a centralized view, you're looking at Sentinel if you've set that up for the more kind of SIEM style stuff, and you've got the Cloud Defender as a kind of the default thing. And obviously every service will have its own kind of log panel that you can click into and look at. But if you're setting up forwarding, that's generally it. You want to look at the centralized spot of Defender and Sentinel for the more security focused stuff. And again, you can obviously export things. You can have stuff from on-prem being piped into your Cloud Defender as well. But yeah, as you said, the docs are by far the best place for looking at that, or a future video coming out.
Yeah, and what I've seen from Sentinel is pretty good too. I mean, unlike CloudWatch, it is actually like a proper SIEM, right? So you can do some pretty powerful stuff there. Cool. Same question, GCP. Obviously, the thing with GCP is a bit tricky, right? Because they have Chronicle, which is a full-on, really quite interesting SIEM. But then they also have Command Center, some other things too. But I mean, anything in terms of logging in GCP that you would raise?
Yeah, so from my experience, I would say Chronicle is probably separate because it's definitely like an add-on rather than what you get from by default. It's definitely like a SIEM product, that's an addition. But in my experience, Google's probably my favorite to work with in terms of logging because things are more logged centrally by default. There's less kind of having to ship things from, like in AWS, for example, CloudWatch, there's lots of different log groups and things like that. But by default, if I spin up a compute engine, it default log standard out to a central place and you can view them all in one go, which I quite liked. Obviously gets more complicated if you have a massive environment and you're going to have to spend a lot of time on that, filtering, aggregating, and all that kind of stuff, which of course there are tools and products that you can use to do that. But generally the same. There's a central panel. You can look at different services logs in the same place, or you can go to that service and look at like a snippet of its logs. And of course, you can always export things to GCS buckets and things like that.
Nice. Yeah, I mean, more centralized is always better, right? So that's good. Again, skimming through, I mean, please just check the doc to be interested. But yeah, obviously each cloud provider has their own detection capabilities, as well as working with partners. Everyone knows Cado in AWS began as quite a tight detection tool, didn't do, frankly, all that much. Now it does a lot of stuff. Similar for Azure on Google Cloud. I don't think there's anything you want to add on onto this, Paul?
Yeah, it's slightly changing now, but these have mostly been more network focused rather than thing detections on actual systems, mostly because they probably don't want to have to build and maintain an endpoint agent to do that. So especially guard duty, I know that they've started to move into doing malware detection on instances if you set it up or allow it, but it's much more been things like seeing obvious malicious network activity, which of course they can do across all their kind of customers much more easily in one go rather than deal with individual hosts. But I think we'll probably see that change more. I think that'll keep happening where they'll maybe even go as far as having, like an EDR-like thing that you can deploy to instances. But I think we're probably a wee while from that yet.
Yeah, it makes sense, I guess. I mean, like in AWS, you have the SSM agent, not built for security, but that could be extended, right? And I know also they're trying to do impactless, so they're doing that WizOrca model of analyzing disks for now, but there are limitations to that. So it'll be interesting to see how this evolves, as you say. Cool. I think we're at the tail end now. But we actually also kind of covered this at the start too. But I mean, Paul, why is responding to incidents in the cloud hard, or why can it be hard, I guess?
Yeah, for me, the main one is data access. So it can be really easy, but it can also be really difficult. So that could be because the data is not accessible, as in you don't have permission to access because of that, as a service kind of model we've talked about a few times. Complexity, like a lot of the time people, especially when you're halfway between, you're working at a hybrid kind of type of deployment where you might not have the staff that are experts in the cloud, they might be kind of having to work across both, and they're usually dealing with desktops that have been compromised, and suddenly they have to deal with a Kubernetes cluster that they've never had to deal with before, and it's very complicated if you not have to deal with it, especially if you don't have specific tooling to handle that. It's one thing to go and take a memory dump and pull a disk and image it, but then how do you deal with all that kind of stuff, or how do you deal with both? If they're both in the same instance, it could have started off on-prem and moved to the cloud, or the other way. I think that just looking at the kind of results of this survey here, I've not really found multi-tenancy to be that much of a difficulty. I think the main one is access to data, and then how to ship it around as well. It's a completely different way to think about it. Usually it's just external hard drive, maybe plug it into an analysis machine, or a SAN or a NAS or something like that. There's lots of different ways to think about it now, where you might need to go via various storage products to get to where you want it to go, and then you think about, how do I analyze it? I need a new system to do that in the cloud, or do I download it and waste loads of time? That's the key difficulty.
Yeah, I mean, same. I haven't heard much about multi-tenancy being an issue. Being just dive in more into those answers. If you open up the SANS paper on that, and yeah, I mean, accessing that data is so tricky. Again, a bit of a bias because that's what we do, but we have a really big team of people whose job is just to work out how to, for example, make sure that you can always get data from the EKS system and then be able to analyze it. And we do that in advance of attacks, right? But I can't imagine the pressure of you're there live, stuff has really hit the fan, and you have to work that out, and you're not a team of a really large team. Yeah, tricky stuff. Cool. Which leads in nicely into what we do. Cado collects all kinds of data from different cloud platforms for security investigations, and then you can analyze it and respond. Check out the free trial on the website if you're interested in more. Thank you so much, Paul, for being, like I said, roped into this, and speak to you soon.
No problem. Cheers.